Hello students, in this video we are going to discuss the Werner's theory of coordination compounds or complex compounds. The scientist Werner proposed this theory to explain the structure of a complex compound or coordination compound. With respect to board exam, it is often coming for 4 marks question. In case of AP state or Telangana state, ఈ క్వశ్చన్ 4 మార్క్స్ క్వశ్చన్గా వస్తుంటుంది. బట్ కాంపిటేటివ్ ఎగ్జామ్లో కూడా దీని యొక్క ఇంపార్టెన్స్ చాలా ఎక్కువగా ఉంటుంది. ఎక్కువ బిట్స్ దీన్ని బేస్ చేసుకుని వస్తుంటాయి. ఫస్ట్ పాయింట్, ద ఫస్ట్ పాయింట్ ఈజ్ every complex compound has a central metal atom or ion. A complex compound has a central metal atom or ion. A complex compound has a central metal atom or ion. Second point is central metal atom or ion has two valencies. The central metal atom has two valencies. What are they? One is primary valency. Second one is secondary valency. Primary valency and secondary valency. The postulates are: a complex compound has a central metal atom or ion. Central metal atom or ion has two valencies. One is primary valency and second one is secondary valency. Now you take one example. Let us take COCl3 dot 6NH3. The name is hexaimine cobalt 3 chloride. Now the geometry is like this. This is also written as CO coordinated with 6 ammonia and 3 chlorines are outer the complex ion. Now the geometry is CO is surrounded by, so it is coordinated by 6 NH3 molecules. 6 NH3 molecules by Deity bonds. You know, in the formation of complex, the species which donate lone pair of electrons to the vacant orbitals of the central metal atom or ion are called ligands. These are called ligands. There are 6 ammonia ligands. Okay. Now, what about the chlorine? Chloride ions are outer the complex. They are outer the complex. Now, in this one, this is a complex. In this one, there is a central metal atom or ion. Next one, the central metal atom or ion has two valencies. One is primary valency. The primary valency is equal to oxidation state. It is equal to oxidation state. And the primary valency is satisfied by negative charged species. Primary valency is satisfied by negative charged species. Negative charged species. What is primary valency? Primary valency is equal to oxidation state. The primary valency is satisfied by negative charged species. Tell me in this case, in this compound, 1, 2, 3. 3 chlorides are satisfying the primary valency. Primary valency is equal to oxidation state. Primary valency is satisfied by negative atom or ions. Negative ions, negative charged ions or negative charged species. Primary valency is indicated by dotted lines because they represent, primary valency represents ionic bond. Dotted lines represents ionic bonds. Ionic bonds. That means these species are ionizable. These are ionizable. Ionizable. You know, ionic bond is non-directional. Non-directional bond. Ionic bond is non-directional. That's why these species cannot give any idea about the geometry of the species. They cannot give any idea about the geometry of the species. Geometry of the species. I repeat once again. Primary valency is equal to oxidation state. Primary valency is satisfied by negative ions. Primary valency is satisfied by negative ion. Now primary valencies are represented by dotted lines. Now these represent the ionic bonds. Ionic bonds are non-directional. These are ionizable. They give the idea about ionizable species. Ionic bonds are non-directional. So these bonds do not give idea about geometry of the species. Geometry. They do not give idea about the geometry. The points I am recalling. Primary valency is equal to oxidation state. In this case, oxidation state is 3. So primary valency is 3. Primary valency is satisfied by negative ions. These are represented by dotted lines. Now, dotted lines represents ionic bonds. Ionic bonds are ionizable. The species represented by dotted lines are ionizable. Ionic bond is non-directional. That's why do not give any idea. Do not give idea about geometry. Do not give idea about the geometry. This is about the primary valency. What about the secondary valency? Secondary valency is equal to the number of ligands around the central metal atom or ion. Secondary valency. Secondary valency. Secondary valency is equal to number of ligands around the central metal atom or ion. Central metal atom or ion. The number of ligands around the central metal atom or ion. Here the ligands are 1, 2, 3, 4, 5, 6. 6 ligands are there. So secondary valency is equal to coordination number. What is called coordination number? The number of ligands surround the central metal atom. That is called coordination number. Here in this case the coordination number is 6. Now these are represented by arrow marks, or these are represented by the dative bonds. Dative bonds. You know, dative bond is a kind of covalent bond. So dative bonds are, these bonds are directional bonds. Because dative bonds are directional, they give idea about geometry. They give idea about geometry of the complex, geometry of the compound, geometry of the compound. Secondary valency is satisfied by negative ligands, sometimes neutral ligands, and in rare cases, neutral ligands, in rare cases, positive ligands. Positive ligands. Okay. I repeat once again. What is secondary valency? Secondary valency is equal to number of ligands around the central metal atom or ion in the complex. It is equal to the coordination number. In this one, coordination number is 6. Number of ligands are 6. These are represented by arrow marks or deity bonds. Deity bond is a kind of covalent bond. Covalent bond is directional. So directional bonds gives idea about the geometry of the compound. Secondary valency is generally satisfied by negative ligands and neutral ligands. In rare cases, positive ligands. Positive ligands. Okay. Next one. If the secondary valency is 2, the geometry is linear. The geometry is linear. Coordination number 2, it gives linear shape. Coordination number 3, it gives trigonal planar. Trigonal planar. Coordination number 4 gives tetrahedral. Tetrahedral or square planar. Square planar. Square planar. Coordination number 5 gives trigonal bipyramidal. Trigonal bipyramidal shape. Trigonal bipyramidal shape. Whereas coordination number 6 represents octahedral or square bipyramid. Square bipyramid. Square bipyramidal or octahedral. Octahedral. Thus, the coordination number gives the shape of the complex. Coordination number 2 represents linear, 3 represents trigonal planar, 4 represents tetrahedral or square planar. Coordination number 5 represents trigonal bipyramidal. Coordination number 6 gives square bipyramidal or octahedral. Octahedral. One more point is the species represented by the coordination, represented by the deity bond, are non-ionizable. It gives non-ionizable species. Non-ionizable species. Non-ionizable species. I repeat once again. Secondary valency is represented by non-ionizable species or the ligands surrounding the central metal atom or ion. It is equal to the coordination number represented by deity bonds. Deity bonds are directional. They give idea about the geometry of the compound. These are satisfied by negative ligands, neutral ligands, sometimes positive ligands. These are non-ionizable species. Now coordination number 2 gives linear, 3 gives trigonal planar, 4 gives tetrahedral, 5 gives trigonal bipyramidal, 6 gives square bipyramidal or octahedral. Octahedral. Okay. The next one is, now we are going to explain some more complex compounds with the same formula. Now we are taking COCl3 6NH3. 6NH3. COCl3 6NH3. Now this is taken as cobalt is the central metal atom. It is surrounded by 6 ammonia. 6 ammonia. Now I take COCl3 dot 5NH3. In this case also cobalt is surrounded by 5 ammonia, but one is chloride. Chloride satisfy both primary valency and secondary valency. Now in this case, COCl3 dot 4NH3. In this case also, I am taking octahedral geometry because coordination number is 6. Now the last one, that is COCl3 dot 3NH3. In this case also, the cobalt is surrounded by 6 ligands. Okay. Now you come to first section. In this one there are 6 NH3 molecules, 6 NH3 ligands, 6 NH3 ligands, 6 NH3 ligands. The nitrogen atom of ammonia is donating lone pairs to the vacant orbital of central metal ion. Clear? Okay. Now the shape is octahedral. Now in this one, the three chlorides can exist at any position because these are non-directional. There is no particular position. They will exist at any position. No problem with them. Okay. Now the first point is central. There is a central metal ion. It is surrounded by some compounds known as ligands. Now Deity bonds represents the secondary valency. Dotted lines represents the primary valency. Okay. Now I go to this one. Now in this one there are 5 NH3 molecules. 5 NH3. There are 5 NH3. Here is chloride. The chloride is satisfying both primary valency and secondary valency in this case. Both primary valency and secondary valency. The remaining chlorides, 2 chlorides can be written at any position, no problem. They can be written at any position. Okay. Now in this case, there are 1, 2, 3, 4 NH3 are there. 4 NH3 are there. Whereas there are 2 chlorides satisfying both primary valency and secondary valency. And here is the free chloride. This is ionic bond. In the last case, there are 3 NH3. There are 3 NH3, while the 3 chlorides are satisfying both primary valency and secondary valency. They are satisfying both primary valency and secondary valency. This is the method of writing the structures of complex compounds. In all these cases, one is the common one. That is, the coordination number is 6. Coordination number is 6. Geometry is octahedral. Coordination number 6, 6, 6, 6 here. Here, primary valency is satisfied by 3 chloride ions. Secondary valency is satisfied by 6 NH3 ions. 6 NH3 ions. Okay. Now when I take this complex compound, this is taken as CO, NH3 taken 6, and here are Cl3. This ionized to produce how many ions? CONH3 taken 6, ionized to produce 1 complex and 3 chloride ions. So totally it can give how many ions? 1 plus 3 means 4 ions it can give when we take this one in aqueous solution. Aqueous solution of this one ionized to give 1 complex and 3 chloride ions. Now when it react with AgCl, it gives how many moles of precipitate? When it react with AgNO3, how many moles of precipitate will form? Precipitate. Now here 3 chlorines are available to combine with 3 AgNO3. That's why it gives 3 mole AgCl. It gives 3 mole AgCl. 3 mole AgCl. Okay. The next one. Now I repeat once again. In this one, primary valency is satisfied by 3 chlorides. Secondary valency is satisfied by 6 ammonia. When we take this one in aqueous solution, it is able to produce 1 complex and 3 chloride. Totally 4 ions it can produce. On action with AgNO3, it can give how many? 3 moles of AgCl, because 3 chlorides are freely available. They react with 3 AgNO3 to give 3 moles of AgCl precipitate. 3 moles of AgCl precipitate. Okay. This is all about the structure of COCl3 dot 6NH3. Now this time I am going to discuss about COCl3 5NH3 5NH3. In this one I told you there is one chloride which is satisfying both primary valency and secondary valency. Now the information about this one, the complex is written as CONH3 taken 5. One chloride is inside the complex. So this one ionized to give one complex ion and two chloride ions. One complex and two chloride ions. So this is the complex ion. Now point number 1. Primary valency is satisfied by 1, 2, 3, 3 chlorides, clear. Secondary valency is satisfied by 5 NH3 and 1 chloride. 1 chloride is satisfying both primary valency and secondary valency satisfied by 1 chloride ion. You remember this chloride ion is non-ionizable. This is non-ionizable. That means it has only 2 ions to ionize. That's why 2 chlorides are ionized. Okay. Primary valency is satisfied by 3 chlorides. Secondary valency is satisfied by 5 NH3 and 1 chloride. Both primary and secondary are satisfied by 1 chloride. So this chloride is non-ionizable. Non-ionizable. Okay. When it react with AgNO3, it forms 2 moles of AgCl only. Why? Because there are 2 chlorides are available. So when it react with AgNO3, it forms 2 moles of AgCl only. One molecule form 1 mole form 2 moles of AgCl. 2 moles of AgCl. Now, anyhow, primary valency 3, secondary valency 6. Both primary and secondary are satisfied by 1 chloride, non-ionizable. Only 2 chlorides are available for reaction with AgNO3. That's why 2 moles of AgCl is formed. Now this time I am going to discuss another compound, COCl3 dot 4NH3. COCl3 dot 4NH3. Now this is a cobalt ion surrounded by 6. Now ammonia, take ammonia, and here is ammonia. Now there are chloride ions. How many chloride? That is, here is the chloride, and here is the chloride. Now tell me in this one, how many chlorines are satisfying both primary valency and secondary valency? First, primary valency is satisfied by 3 chlorides. Secondary valency is satisfied by 4 NH3 molecules and 2 chlorides. That's why 6 is the coordination number or secondary valency. Now both primary and secondary valencies are satisfied by how many chlorines? Satisfied by how many chlorides? 2 chlorides. You remember these 2 chlorides are non-ionizable. These 2 are non-ionizable. These 2 are non-ionizable. Therefore, the complex on ionization gives 1 chloride only. It ionizes to give how many chlorides? 1 chloride. So on ionization, how many ions are formed? In CO, NH3 taken 4 Cl2. The complex on ionization forms 1 complex ion and 1 chloride. This is surrounded by 4 NH3 and 2 chlorides. Thus it is giving how many ions in aqueous solution? In aqueous solutions it can produce one complex and one chloride, totally 2 ions. What happens when it react with AgNO3 solution? When it react with AgNO3 solution, it combines with 1 chlorine to give 1 mole AgCl. It gives 1 mole AgCl. 1 mole AgCl. Now, primary valency is satisfied by 3 chlorides. Secondary valencies are satisfied by 4 ammonia and 2 chlorides. Here, primary and secondary valencies are satisfied by 2 chloride ions. Now, in aqueous solution, this one ionized to give 1 complex and 1 chloride. Thus, it gives how many? 2 ions. On action with AgNO3, it gives 1 mole AgCl precipitate. The last one is COCl3 dot 3NH3. In this case, cobalt ion is surrounded by 3NH3 molecules and 3 chlorides. The 3 chloride ions are satisfying both primary valency and secondary valency. They satisfy both primary valency and secondary valency. Now clearly, primary valency is satisfied by 3 chloride ions. Secondary valency is satisfied by 3 NH3 and 3 chloride ions. Totally 6 is our secondary valency. Both primary and secondary valencies are satisfied by, these are satisfied by how many chlorides? 3 chloride ions. 3 chloride ions. Now, the geometry of the complex is like this. CO NH3 taken thrice, NH3 taken thrice, Cl3. Now in this one, there is no ionizable ion because the 3 chloride ions are involved in covalent bond or dative bond. So dative bonded species are non-ionizable. Non-ionizable. So in aqueous solution, it do not undergo any non-ionizable substance. This is non-ionizable. So ions producing is equal to 0. Now when it react with AgNO3, there is no precipitate. No precipitate will form. No precipitate will form. Okay. This is all about the Werner's theory. Okay. Thank you.